Let's prepare on TRB Polytechnic exam 2017 civil engineering question paper. So in this TRB question paper, we have left out some 3 questions in steel structures alone. So many of you has been continuously asking about the solutions for that. So for that 3 questions alone, I have given the solution in this video. So question number 128. Determine the economical depth of the welded plate girder of span 24 meter to carry superimposed load of 35 kilonewton per meter. Avoid stiffness and use Fe415 steel. So here, this is the formula, that is the economical depth D is equal to mk by Fy the whole power 1 by 3, that is cube root. Okay, so first, what is this m means? It is nothing but the moment, and k, and it is a factor, and Fy we know it is the yield strength of the steel. So here let us find the k value first. So k value is equal to 67 into epsilon w. So it is nothing but the strain of the web that is acquiring. So to calculate the strain of the web, it is root of 250 by Fyw. So Fyw means it is the yield strength of the web. So we know that the yield strength is 250. So 250 by 250, it is root 1, so 1. So you may think in the question they have given use Fe415 steel like that, but whenever they we substitute the value for Fy, you should substitute 250 only. Fu value, that is the ultimate strength, if you are substituting, means you have to take Fe415. So here Fy, no, so 250 only you should substitute here. So which is equal to 1, and then we want to find the moment. So we are considering it as a simply supported beam, and WL square by 8 will be your moment. So W, the load is given, length is also given. So when you calculate, you will be getting the moment value. So when you substitute this moment value, this K value, and Fy250 in the formula, you will be getting the answer as D is equal to 877 mm. So the nearest value that is given in the option is 1000 mm. So always you should provide extra only. If extra is provided, no problem. You shouldn't provide the value lesser than the calculated value. So here 1000 is nearer to that, so we can go for the option 1000 mm. The next question 129. A tension member consists of two angles 60 cross 60 cross 8. So angles means here 60 cross 60 is one length and another length. That is, we'll be having two legs now, and 8 is the thickness. And then the angles being placed back to back on the same side of the gusset plate. One leg of each plate is connected to the gusset plate. The outstanding legs are also connected by tack rivets. Find the safe tension for the member. Use 16 mm diameter rivet. So this is the diagram I have drawn here. So this will be your gusset plate, and these are two angles fixed. So as you can see here, the connected legs are connected by the rivet, and the outstanding legs also, it is connected by a tacking rivet. So this is the diagram. So now to calculate the safe tension that has to be, or that can be placing in that member, that is the tension member, is PT is equal to net area into the stress. Okay, so to find the stress here, the formula is 0.6 times the Fy. So 0.6 into 250, so it is 150 Newton per mm square. The next thing is to find the area, net area. So if this is the case, means the formula to find the net sectional area is area net is equal to A1 plus K2 into A2. Okay, so what is this A1 and A2 means? A1 is the net sectional area of the connected legs. So these both are connected legs. So this alone you should find the net sectional area. Net sectional means you have to minus the rivet size. And then A2 is the gross area of the outstanding legs. So the gross area of this outstanding legs. And then K2, the factor here K2 is equal to 5A1 by 5A1 plus A2, or you can simplify it as 1 by 1 plus 0.2 A2 by A1. So here I have found the A1 first. So we know that the length is 60, no? So here, this is the diagram now. So 60 plus 60 minus 17.5 for one rivet and 17.5 for another rivet, because We know the diameter of the rivet is 16 mm. So to find the whole size of that rivet, you have to add 1.5 mm additional to that. This we have already studied in the rivet lecture. Okay. So when the diameter is less than 25 mm, 1.5 mm is necessary to be added. So here it is 17.5. So when you minus both, you will be getting 85 mm as your length, and into its thickness 8. So you will be getting the area as 680 mm square. And then the area 2, that is your gross area of the outstanding legs. So outstanding legs, you shouldn't take it as 60, because already here 8 mm thickness is taken by the connected legs, no? So the outstanding legs will be 60 minus 8, that is 52. So here 52 into 8, here also 52 into 8. So only I have written as 52 into 16, like that I have written. So it is 832 mm square. So with this A1 and A2, you can calculate the K2, that is 0.803. So with these three values, you can calculate the net sectional area, that is 1348.096 mm square. So when you multiply this value and 150, you are getting the answer is 202 kilonewton. Okay, so this is somewhat nearer to the option B, which is 203 kilonewton. So we can go for that option. Question 130. The sliding end of a roof truss rests on a brick wall through a concrete pad. The maximum normal reaction at the bearing is 125 kilonewton. The principal rafter is inclined at 30 degree to the main tie, which one is horizontal. What will be the factored force in the principal rafter? So you may think the question is very difficult, but if you know the components of these things and where it has to be placed, means only simple technique is used here to find the answer. So now when you see the diagram, you can realize that. So see here, this is the diagram. So this will be your principal rafter. So principal rafter means when there is a tie. Tie means it's a horizontal member. So if this is your tie and here two columns or walls will be placed. So the first member like this only will be called as principal rafter. Okay. So here we are taking this as principal rafter and this is tie, and it is placed on a bearing which is mounted on a wall. So that also we have drawn here a bearing and a wall, and the angle is given as 30 degrees. So I have taken 30 degree here. That's all. The reaction at the bearing is 125 kilonewton, and we can take this as F and this is H. So you can use the simple equilibrium equations. Sigma V is equal to 0. So you'll be getting F sine 30 plus 125 is equal to 0. So F will be equal to 250 kilonewton. So the sign is minus, so it is in the opposite direction. So it is the value 250 kilonewton. Thank you and keep watching.